Hi everyone, welcome to today's video on expanding and simplifying algebraic expressions, and then we're also going to go over some examples later. So when you have a term outside a bracket, you need to multiply it by each term inside the bracket. This process is called the distributive property. So whatever is outside gets distributed to everything inside. So for example, we have 5 times x plus 3. So that 5 is getting distributed to the x, and it's also getting distributed to that positive 3, giving us 5 times x plus 5 times 3, which can then be simplified to 5x plus 15. In our next example, we have x times 3 minus x plus y. So we have 3 terms inside of the bracket, the 3, the negative x, and the positive y. And we distribute this x that's outside the bracket to every single term inside the bracket. So it gets distributed to the 3 to make x times 3. It gets distributed to the negative x to make x times negative x. And it gets distributed to the y to make x times y. And we're just adding the products together. So in the end, this simplifies to 3x minus x squared plus xy. And in our third example, we have nestled brackets. So we have brackets within brackets. So when you see this, all you have to do is first distribute to the innermost brackets and then later distribute to the outermost brackets. And you can simplify easier that way. So I'll go through this example with you now. So we're going to rewrite everything before we get to the part that's being distributed. So the negative 4 times x minus 1. So I'm going to write down 2 times 3. And now I'm going to distribute this negative 4 times x to give us plus negative 4 times x. And I'm going to distribute this negative 4 to the negative 1 to give us plus negative 4 times negative 1. And we have this bracket here at the end, so I'm just going to draw that in. Now we can simplify further, so I can write 2 times 3. And negative 4 times x is going to give us negative 4x. And negative 4 times negative 1 is going to give us plus 4. Now I can simplify further within the brackets before distributing, so I'm going to do that. So now I have 2 times, and 3 plus 4 gives us 7. So 2 times 7 minus 4x. Now this 2 can be distributed to both the 7 and also the negative 4x. So I'm going to do that now, giving us 2 times 7, which is 14, and 2 times negative 4x, which gives us negative 8x. And that would be our final answer. So now I'd like to go over some examples with you guys to further drill this in. And make sure you guys are pausing the video and attempting these on your own and then watching my solution afterwards. In our first example, we have negative 9 times x plus 3. So that's just going to be negative 9 times x, which is negative 9x, plus negative 9 times 3. So negative 9 times 3 is going to be negative 27. So that is our answer. In our next example, we have something being distributed here, and we have something being distributed here. So we'll start with the one on the left first. So this 2 needs to get distributed to both the x and also to the positive 1. So 2 times x is going to be 2x, and 2 times 1 is going to be 2. So that's how we get that. And now we have to distribute this negative 4 to the x and also to the negative 3. So negative 4 times x is going to be negative 4x. And negative 4 times negative 3 is going to be positive 12. Now we can gather like terms. So 2x and negative 4x are like terms. So 2 minus 4 is going to be negative 2x. And positive 2 and positive 12 are both constants, so they are also like terms. So 2 plus 12 is going to be positive 14. So our answer is negative 2x plus 14. For our next example, we're distributing this negative 5 to the 4y and also to the negative 2. So negative 5 times 4y is going to be negative 5 times 4, which is negative 20, and then also y. And negative 5 times negative 2 is going to be positive 10. So our answer is negative 20y plus 10. For example 4, we have x times 3x minus 5. So x times 3x is going to be 3x squared. and x times negative 5 is going to be negative 5x. So our answer is 3x squared minus 5x. For example 5, we have negative 3w times 4w plus 1. So this needs to get distributed to the 4w and also to the positive 1. Negative 3w times 4w is going to be negative 3 times 4, which is negative 12, and w times w is w squared, so negative 12w squared. And negative 3w times positive 1 is just negative 3w. So our answer is negative 12w squared minus 3w. For example 6, we have negative 5p plus 3, and all of that times 2p. So when you're distributing, every term in this bracket, so both the negative 5p and the positive 3, need to get distributed to every term in the other bracket, so the 2p. So we could illustrate it like this by showing that both of these are getting applied to this 2p. Or you can illustrate it like this 2p is getting applied to everything inside of this bracket, whichever one you prefer, since the order you multiply doesn't matter. So I'm just going to show it this first way for something different. So negative 5p times 2p is going to be negative 5 times 2, which is negative 10, and p times p makes p squared. And then positive 3 times 2p is just going to be positive 3 times positive 2, so positive 6, and then p. So our answer is negative 10p squared plus 6p. For question 7, we have negative 5a times 7a squared minus 3a plus 1. So negative 5a times 7a squared is going to be negative 5 times 7, so negative 35. And then a times a squared, remember when you're multiplying variables with the same base, you add their exponents. So 1 plus 2 is going to be a to the 3. Negative 5a times negative 3a is going to be negative 5 times negative 3, so positive 15. And then a times a is going to make a squared. And lastly, negative 5a times positive 1 is going to be the same thing, so negative 5a. So our answer is negative 35a cubed plus 15a squared minus 5a. For question 8, we have 2 times p minus q plus 2 times negative p plus q. So this 2 needs to get distributed to everything inside this bracket. So 2 times p is going to be 2p, and 2 times negative q is going to be negative 2q. And positive 2 needs to get applied to everything inside of this bracket. So positive 2 times negative p is going to be negative 2p, and positive 2 times q is going to be plus 2q. So if you'll notice, the positive 2p cancels out with the negative 2p, and the negative 2q cancels out with the positive 2q, so you're left with 0. Another way you could solve this is by factoring. So if you notice that a negative 1 can be factored out of this expression, you could actually rewrite this as 2 times p minus q plus 2 times negative 1 times p minus q. And that's because we factored out this negative 1. So that means you have to divide every term inside this bracket by negative 1. So that's how we got this expression, which then simplifies to 2p minus q minus 2p minus q. And if you notice, we're adding, we have a positive 2p minus q, and we have a negative 2 times p minus q. So those would cancel. It's like saying, let's say p minus q is equal to a, for example. So it would be like saying 2 times a minus 2 times a. Those things would cancel out with each other, giving us 0. So whichever way is easier for you. That's just a little trick. For question 9, we have nestled brackets, so we're going to work with the innermost brackets first and then work our way out to the outermost brackets. So the innermost brackets would be right here. So the first thing we're going to do is write everything up until the part that's getting distributed. So we have 4 times 3k. And then while it looks like there is no number here, this negative sign means a negative 1 is getting distributed to the brackets, because this is the same thing as negative 1 times 2 plus k. So we can write that now. So that's going to be -1 times +2, so -2, and -1 times +k, so -k. And then we can close our bracket here. Now our next step is to simplify anything further inside the brackets if we can. So we have some like terms here. The 3k and the -k are like terms, so we can simplify that further in our next line. So that gives us 4 times, and now 3k minus k is 3 minus 1, so 2k. And then we also have a -2 left over from right here. So now that we don't have any more like terms within the brackets, we can distribute our -4 to all of our terms within the brackets. So that gives us 4 times 2k, so 4 times 2 is 8, and then k. And 4 times -2 is -8, so our answer is 8k minus 8. For question 10, we also have some nestled brackets, so we're going to work with our innermost brackets first again. So that would be right here. So our first thing we're going to do is write our -p times, and then q times 2 is just 2q, and q times p is just going to be qp. And then we have a plus 5p. So now we're going to see if we can simplify further within the brackets, and it doesn't look like we can because we have a p over here, a q over here, and then a q times p. So no like terms. So now we just have to apply this -p to all of our terms within the bracket. So we're going to get -2qp, and then -p times qp is going to be -q and then p squared. And -p times 5p is going to be -5p squared. And so our answer is -2qp minus qp squared minus 5p squared. For question 11, we have something that needs to be distributed here, something that needs to be distributed here, and also some more distribution here. So 3 things. So let's start with the one on the left. So 4j times j is going to give us 4j squared, and 4j times -3 is going to give us -12j. -2 times j squared is going to give us -2j squared. -2 times +3j is going to give us -6j. And -2 times -1 is going to give us +2. Finally, this is the same thing as -1, so we'll do -1 times j squared is going to give us -j squared, and -1 times +5 gives us -5. Now we can collect like terms and simplify, and if you're having some trouble with collecting like terms, you can see my other video on collecting like terms for some more clarification. So first I'm going to collect our highest power, so our j squareds. So we have a 4j squared, a -2j squared, and a -j squared. So collecting those, we get 4j squared minus 2j squared, which gives us 2j squared. And that 2j squared minus another j squared gives us j squared. So we have j squared, and now I'm going to collect our j's. So we have -12j, -6j, and that's it. So that gives us a -18j. And lastly, for our constants, we have a +2 and a -5. So -5 plus 2 is going to give us -3. So our answer is j squared minus 18j minus 3. For question 12, we have -1/4 being distributed to everything in here, and a -3/5 being distributed to everything over here. So let's start with the one on the left. So that's going to give us -1/4 times 4u, and then we also are adding -1/4 times -3v. And for our next part, I'll do that in blue. We're distributing our -3/5 to our 6u, and we're also distributing our -3/5 to our -10v. I kind of got cut off at the end there. And if you're confused about these plus signs here, it's just because every time we multiply like we distribute to a term inside the brackets, we need to separate that with a plus sign. So this -1/4 being applied to the 4u needs to be separated from this -1/4 being applied to the -3v. So we separated it with this plus sign here. And then also this -3/5 being applied to the 6u needs to be separated as well with a plus sign. And it also needs to be separated from the -3/5 being applied to the -10v. So you need to separate this with plus signs. If you're still confused, just rewatch this question from the beginning. But moving on, we have -1/4 times 4u. So since we're multiplying by 4 but also dividing by 4, that would cancel out as 4 divided by 4 is 1. So we can cancel that. So now we're just left with -1 times u, which gives us -u. And now for over here, we have -1/4 times -3v. So a negative times a negative makes a positive. And then 1 times 3v is just going to be 3v, and we're dividing by 4. So we get 3v over 4. Now for this one over here, we have a negative times a positive, so that's going to be negative. And then 3 times 6u is going to be 3 times 6, which is 18, and then u, and we're dividing by 5. So we get 18u over 5, or minus 18u over 5. And for this last one over here, we have -3/5 times -10v. So negative times negative is going to give us a positive. And then we have 3 times 10 over 5. So we could do this like 3 times 10 is 30v over 5. And 30 over 5 is 6. So we would actually get 6v. Or I'm going to show you this other way to do this, where we simplify earlier. And my other way of doing this is recognizing that we're multiplying by a 10 and we're dividing by a 5. So 10 divided by 5 would give us 2. So then 3 times 2 gives us 6. And then we also have our v, so 6v. And I could show this in another way by writing this whole thing out. So we would end up with 3 times 10v divided by 5. And we could actually rewrite this 10v as 2 times 5 times v. So the 5 and the 5 would cancel, just leaving us with 3 times 2 times v, or 6v. And now we just have to gather like terms and simplify. So -18u over 5 and -u are like terms, and +3/4v and 6v are like terms. So starting with our u's, we need to get the same denominator so that we can add. So -u is the same thing as -u over 1. And -18u over 5 has a denominator of 5. So the quickest way to get the same denominators is to multiply this by 5 over 5. So that would give us -5u over 5 minus 18u over 5. So -5 minus 18 is -23u over 5. So that's how we do that part. And now to do our v's, to get the same denominator, we need to multiply 6v by 4 over 4. So if we multiply 6v by 4 over 4, and remember 6v is the same thing as 6v divided by 1, we get 24v over 4. So now we have 24v over 4 plus 3v over 4. So 24 plus v is 27, so plus 27v over 4. So our answer is -23u over 5 plus 27v over 4. And we can also rewrite this like this if you'd like. They're the same thing. And lastly, we have this word problem. So a mobile car detailing service charges $40 per visit plus $25 per hour for detailing. Write an algebraic expression that describes the total charge for one car detailing session. So if we let h equal the number of hours worked on the car, and we let C equal the total charge, then our total charge or total cost C would be equal to $25 times the number of hours worked, so $25 per hour. And then we also have this $40 per visit charge. So no matter whether you visit for 0 hours, 1 hour, 2 hour, 3 hours, you have to pay this $40 base fee. So we need to add $40. So what this expression means is our total cost per visit is going to be $40 regardless of how long you stay, plus $25 times the number of hours you stay. So now they want us to use our expression to find the total charge for a 3-hour detailing session. So if we know we're going there for 3 hours, we know H is equal to 3. So we can use our expression C equals $25, and instead of H, we're going to sub in 3 because we're going for 3 hours, and then we have to add our $40 base charge. So that gives us $75 plus $40 for a total of $115 for a 3-hour detailing session. Part C says, suppose all charges are increased by 50% for weekend appointments. Write a simplified expression for these weekend service charges. So let's let the total charge for a weekend be C sub W for weekend. So if all our charges are increased by 50%, we can multiply our entire regular expression, so our regular cost, by 1.5. If we multiply just by 0.5 for 50%, then that would be 50% of our original cost, which we don't want. We're not giving a discount. It's 50% more. So it needs to be that 100% of the C plus an additional 50%. So that's why we're multiplying by 1.5. So we can rewrite this since we know what C is. C is equal to $25 per hour plus our $40 base charge. So using our distributive property, we can distribute this 1.5 to all our terms inside the brackets. So that gives us $37.5 per hour plus a new base rate of $60. So this would be our answer. And now they want us to use our simplified expression from Part C to calculate the cost for a 3-hour detailing session on the weekend. So our total cost for the weekend is equal to $37.5 per hour, but we're doing 3 hours, remember, because we're doing a 3-hour detailing session. And then we have to add our new base rate of $60. So solving, we get $112.5 plus $60, and that gives us our weekend charge of $172.50. And that would be your therefore statement, which you should include at the end of your word problems. And that's it for today's video, so thanks again for watching. I really appreciate it, and I will see you soon in the next video.